सर स्प्रिंग से रिलेटेड क्वेश्चन फ्रिक्शन वाले पार्ट में है.
Spring.
यस सर.
String, not spring, string, string, string.
स्ट्रिंग.
Yeah, it is from the friction.
ओके सर.
सर
Yes.
डीएस कुमार भावी कट्टी में स्प्रिंग वाले भी SPRING स्प्रिंग वाले भी क्वेश्चन हो रखे हैं.
No. If don't need to go too much in detail. Spring
Okay.
questions are not that much important. Okay.
Okay, sir.
What are the type of numericals I have discussed in the class? You just have to solve them. Okay. So because when you, I just want to tell you one thing. When you open the book SS Bhavikatti or DS Kumar or RK Rajput, whatever book you have with you, there are number of numericals, number of types of numericals are there. Okay, so you should not do all the types of numericals. You just concentrate on the types of numericals which we have discussed in the class. For example, Lamb's theorem we have discussed, simple string problems. Then we have discussed about the sphere problems, if you can remember, and we have discussed some simple problems on beam. So all these types of problems you have to identify from the book. Which are the questions, which are the types we have already taught in the class, and according to that type you have to solve the numerical. If you go on solving number of numericals, that will not serve your purpose, because it may give you confidence, or it may give your morale down, because if you're not able to solve that particular numerical, then you will think that I am not able to get confidence. That's why I'm saying concentrate on the class lectures, and whatever the type of numericals I am discussing in the class, just identify those types of numerical in the book and solve those numericals. Just like spheres, you have to see all the types of sphere, whatever sphere they questions in the book, solve them. Okay. Similarly, all the problems, just like the of Lamb's theorem, string based problems are there, and one cable is attached. Some those types of numericals I have also discussed. So identify those types of numerical and solve them. And thirdly, simple problems of beam, Varingan's theorem I have discussed with you. So simple problems of beam you can discuss. In the second module, we will be discussing too much in detail for the beam part. So simply you can solve the very basic problems of the beam right now. Now the last part which is left here is ladder friction of the first module. So screen is visible to you. Screen is visible, students?
Yes, sir.
Okay. I am just making a diagram for the ladder friction, then I will dictate the question and then I will explain how you have to do it. Okay. Let's see the diagram first of all. Sorry. So this is the ladder here, AB is the ladder, okay. And here, this is the center of the ladder. And this is the point X. And this total length is 6 meters. Fine. So I am dictating the question first of all. Just write down the problem and then I will explain how you have to solve this problem. A 6-meter long uniform ladder having weight 300 Newton, having weight 300 Newton is placed against a vertical wall. Its inclination with the ground is 60 degree. You can see the inclination here. I have forgot to make the inclination here. Inclination with the ground is 60 degree. At what distance from the lower end of a ladder? At what distance from the lower end of a ladder a man having weight 800 Newton should climb before the slipping of the ladder starts. Full stop. The coefficient of friction between the contact surfaces is 0.2. So this is the question. Should I repeat the question? It is clear to you, or you have completed the problem statement of the problem?
Repeat, sir.
So I am repeating it once again. See it. 6-meter long uniform ladder having weight 300 Newton is placed against a vertical wall. Its inclination with the ground is 60 degree. At what distance from the lower end of a ladder a man having weight 800 Newton should climb before the slipping of the ladder starts. The coefficient of friction between the contact surfaces is 0.2. So this question is clear to you. Should I explain it?
Yes, sir.
See, this is the ladder here AB, and this is inclined against a vertical wall and the horizontal floor. Okay, what is happening? The length of the ladder is 6 meters. A man whose weight is how much? 800 Newton starts moving from the point A and moving up the ladder. It start moving from the point A and it is moving along the ladder. But what happens once he reaches the point C? Let us say this point is C. This point is C, and this point is G. Let us say, sorry, when the man reaches to the point C, ladder starts slipping. So when the ladder starts slip, what man has to do? He has to climb from this position C onto the floor or on the ground. Okay, so you have to calculate the distance from the lower end of the ladder. That means you have to calculate the x distance to how much this man is able to reach on the ladder, and after this point ladder starts slipping and he has to climb from the ladder and onto the ground, so as to save himself. So this is the question. See, what is important in the ladder problem, you have to see the motion of the ladder, in which direction it is moving. Can you can you imagine the situation here? When the ladder here is, when it is slipping, So when it slip, what will happen? It will come down this point, and or this end of the ladder, or this end of the ladder will move down, and this end of the ladder A will move to this side. It is simply concept. Okay. So what is happening when this end moves down and this end also moves to the left hand side? This is the simple basic. So have you understand this concept? When the slipping starts, it will come down and it will move left hand side. So what will happen? This is the actual motion of the ladder. So against this, we have to form the coefficient of friction. So what will be the FBD? See there very carefully. This point A, here the ladder is attached to the floor, and let us say the reaction here is, let us say reaction here is RA, and here with this point here the reaction here is RB. And other thing, when point B is slipping downward, so coefficient of friction will act in the opposite direction. So what will be coefficient of friction? That will be mu into RB. Similarly here, when the A portion of the ladder is trying to move on the left side, so on the right side there will be coefficient of friction, and let us say that is mu into RA. So in all, how many forces are now there? W, which is the weight of the ladder, W1, which is the weight of the man, which is reached up to the point C. After that he has to jump, otherwise ladder will slip and he can get injured, so he has to jump from here. At the point A, this ladder is in contact with the floor, so reaction here is RA, let us say. Similarly here it is RB, and this is vertical, this is not an angle. So I am just making it little bit clear if it is confusing here. So this is vertical here. Okay, this is vertical here RB, and this is mu RB, coefficient of friction. So how many forces are there? This is, let us say this is W, this is W1, weight of the man, the weight of the this ladder, and at the point A we have one force, that is RA, and here we have another force, that is RB, and also we have mu RB, and we have mu RA. So in all we have 1, 2, 3, 4, 5, 6. So the other forces we have 2, 2, 4 and 2, 6. So total the other 6 forces, or the FBD of the ladder with respect to the floor and the wall. So this is clear how I have made the FBD. Should I explain it once again, or it is clear to you? RA, RB.
Sir, please explain it again.
Okay. One more time. Yes.
तो इसमें हम लोग मूवमेंट नहीं कंसीडर करेंगे W1 का?
Listen, we will consider the movement, but I am right now I am concentrating on the FBD first. Without FBD, how you can go to movement? Okay. First, we have to see the FBD part, and then we will go to movement. So I am explaining once again. See, this is the ladder here. So I am just making it once again for you here. If you have any issue, this is the ladder. Okay. When it slips, what happens? This is the natural phenomena, or this conceptual phenomena. When it slips, what will happen? This side will come down like that. It will come like that. If you can see that by the dotted line, it will come down, and this portion will move to the left hand side. This is slipping. It cannot slip in this direction because of the force of gravity. Fine. When it slips, it will move down. So this side, or this portion will move to downward side, and this portion which is connected with the floor will move to left hand side. So this is the motion of the ladder during the slipping or during the motion. So we have to see the coefficient of friction. So when the motion in this direction for this part here, so coefficient of friction will be mu RB, because here the point is B. Similarly, the point of contact here is A. So when it will move to this side, so here it will be mu into RA. This is the coefficient of friction, and weight which is acting downward for the man and the ladder shown here, and plus here. This is the in contact here, RA, and this is also here in contact. This will be RB. So these are the 6 forces that you have to see. Now you will go for the equation of statics. You can see that by applying equation of statics, what we have equation of statics, Fx is equal to 0, summation Fy is equal to 0, and movement at point A, we have to take the leftmost point, so movement at point A should be equal to 0. Now you can take summation Fx. What are the forces in the horizontal direction? You can see here, mu into Ra minus Rb should be equal to 0. This is equation number 1. Similarly, for the vertical components, how many we have? You can see mu Rb in the vertical direction plus Ra in the vertical direction, and W and W1 are in the downward direction. So we will take these two equations, and the third one is movement equation, what the student was saying. Now we will take the movement equation. So see, what is the movement at point A? Ra into 0, because there is no perpendicular distance.
Yes, sir.
Now see here, minus W1 into how much? See, I am explaining it here very carefully. See here, see there. This is the force here. This is W. This is W1. Now, if I make like that, what will be the perpendicular distance? If I draw it here like that, but perpendicular distance will be this one. Similarly, for this force, this will be this one. Okay. So this will be W1 into this distance will be X cos. This is the angle here is
60.
60. Fine. Similarly, minus W into this is W here, and W that is center. So base upon hypotenuse here. This will be how much? This is total length is 6 meters. So this will be how much? 3 meters. 3 cos 60. Now comes to this force RB. RB is acting here in the anti-clockwise direction. So this will be plus RB into what is the distance? Perpendicular distance. This one is the perpendicular distance. So perpendicular upon hypotenuse. This will be 6 sin 60. And last one is mu RB in this direction. So this is also anti-clockwise, and perpendicular distance will be this one. This will be plus mu RB into how much it is? This one. This upon this. This will be 6 cos 60. Fine. So this will be based upon hypotenuse 6 cos 60, and this should be equal to 0. So you have the 3 equations now. Equation 1, equation 2, and equation 3. And from these 3 equations, you know the value of W, you know the value of W1. You can calculate the value of RARB. You also know the value of mu. So calculate the value and tell me the exact value what you are getting for X. Now you have to do the calculation part only. Calculate it and tell me the value what you are getting.
Value of RB, please.
Your voice is not coming, it is breaking.
RA and RB.
RB, what you have calculated?
Sir, R is 365.38 and RB is 2.076.
Little difference. I think not little is too much difference. See the answer here.
Okay, sir.
RA is 1057. And RB is 211.54. RA is 1057 and RB is 211.54. And once you calculate X, X will be 1.94 meter. X will be 1.94 meter. So this ladder problem is very important because in examination this problem also can come. So are you able to find the solution of this answer?
सर RA 1057.6 है.
Yes. On the right side you can see.
Yeah, okay.
All of you getting the answer?
सर x की वैल्यू कहाँ से निकाली?
From the moment equation. See the moment equation, W1 into X cos 60. From here you get the value of X. So have you got the answer? X is equal to 1.94.
No sir.
No sir.
RARB you have get.
RARB आ गया.
Then just put the values in equation.
19.40.
1.94 meter. Check your calculation. Decimal places here and there you can see the digits. You are saying 19.4 to 1.94 meter.
सर
Yes.
हमने सर वेट के साथ एंगल क्यों नहीं लिया 60 डिग्री
Which weight?
सर W1
Because we will assume that this weight is acting vertically downward. That's why.
ओके सर
So should I proceed now?
Sir, wait.
Okay. Should I change this slide now?
Sir, W1 is 800 Newton.
Yes. W1 is 800 and W is 300.
Okay.
Sir, put down.
Got the answer?
1.94.
Sir, I am
Yes,
getting
sir.
1.93.
94 is exactly the same answer. You can see the
Sir,
downside of the
okay, sir.
1.94 meter. Okay. So this problem is clear to you. Ladder problem you can do. In examination, ladder problem also can come. So I will be giving you assignment in that some problems of ladder will be there. So try to solve them also. So that was the numerical of ladder friction. Now you can see the next article, resolution of a force into a force and couple. This article has been used in the problems of beam, distributed force problem, which you are not able to solve some numericals of the beam, which I have been given by the some students. So see this article, this is very important article. If let us say this is rigid body here, this is a rigid body, and if we say there are n number of points on this body and we take any 2 points here. Let us say we have taken point A and the force F is acting in this direction. So what is the meaning of this statement or this theorem? Resolution of a force into a force and couple. So what we can do, the force which is acting at the point A, we can shift the force to the point B. So listen it once again. If a force F is acting at the point A, we can shift the force which is acting at the point A to the point B together with a couple. So this is the theorem. So resolution of a force into a force and couple. So you can see here what I have done. at the point we have taken a point B here, and the distance between, let us say, perpendicular distance we are saying right now. So you have to make it very clear. Perpendicular distance between these 2 points A and B is x, let us say, and I have introduced two equal and opposite forces F, each of magnitude same, which is acting at the point A. This is point A. So at the point A, force F is acting. And so I have introduced two equal and opposite forces F at the point B. So what will happen now? You can see, if I introduce two equal and opposite forces F here, so net effect is zero. So there will not be any problem. And this is the perpendicular distance. So now you can see here this force and this force. This forms a couple. So what is a couple? You know very well. Two equal and opposite forces constitutes a couple. Okay. F1, F1. These two are the forces here, and these two forces are acting in opposite direction, and they are parallel forces. About this point, if they are rotating, so they forms a couple, and they have a moment which is called as F1 into X. So at the point B here, this constitutes a couple. This two unlike two like parallel forces here, and they forms a couple. So whose moment is F into X. We have just converted this into, and the force which is acting at the point A is shifted to the point B. So this is the theorem. Okay. So we have shifted the force which is acting at point A to act at some other point B together with a couple, and whose moment is F into X. So this theorem is clear to you. So I am again repeating, if a force acting at the point A, we can shift it to the another point B together with a couple, and whose moment is F into X. For that, what we have done, we have introduced two opposite forces F here of same magnitude, and net effect will be zero. And this force, and you can say this force and this force constitutes a couple because they are two parallel forces, and we know it very well. If two parallel forces are rotating, and they have a rotational effect, and they forms a couple, and whose moment is F into X, F1 into X, this distance, let us say this distance is X, so it will be F1 into X. So movement will be F into X, and the force which is acting at the point A is shifted to the point B. So this is the theorem. This is also a very important theorem. So make a note of it. It can come in examination for 2 marks. What is how you can resolve a force into a force and couple? So this you have to write this statement, and then you have to make the diagram. So this is clear to you?
So what is the third diagram?
See, third diagram is that what I have done, I am just explaining it once again. This force and sorry, this force, this forms a couple, this force and this force, because you can see here, couple, what is a couple? Two equal and opposite parallel forces. These are equal and opposite parallel forces. So this force and this force forms a couple, and whose movement will be total magnitude of the force into perpendicular distance. So I have taken this, converted this couple into its movement F into X. What is the direction here? You can see direction is clockwise. So I have taken it clockwise and written here clockwise. Okay, and the second force which is acting here, this is F, this remains same here. F is here. So I have shifted the force which is acting at point A. Here you can see the point is at A, sorry, the force is at point A, and now we have changed the force from the point A to the point B. So this is the theorem, and this you have to know while solving the problems of beam. Okay, so I will just please mute your mic. I think some students unmute the mic. Please mute it. This is the theorem. So I will just explain one numerical so that you can able to solve the problems of distributed forces. See this one numerical here. So you have to calculate RA, RB. Can you able to do it? Step number 1. I think you can make it. This is, let us say this angle is 50 degree. I will explain only these two parts, okay? Rest part you can do it. You know it very well how to resolve UDL into point load. You know it very well, na? I have already explained you in the previous classes how to resolve UDL into point load. So I will explain only this part, how you have to solve this part and this part. I will explain only this part and this part, okay? See, I am just making the ABD here. What is this hinge support? What will be the equations? HAVA, okay? If you can remember, and this is VB. This is roller support, so we have only one reaction, and this is hinge support, so we have two reactions. And here you can see 40 kilonewton is at an angle, so this will be 40 cos 50. This will be 40 sin 50. And this is how much? FE. This will be how much? Tell me if you can remember. What is the value here?
120.
120 kilonewton.
120. Very good. And this is, let us say G1, so this will be 1 meter and this will be 1 meter. So no, you know it very well, so I am not going in detail to that one. Now comes to this one. Actual problem comes here. See, this is the point here, the force is acting here. So this is the theorem, you can remember, I have done it. At point A, force F is acting, I have shifted it to some other point B. Okay, so see here, at this point force 20 kilonewton is acting. So I will shift this point here. This will be 20 kilonewton. And what will be the movement here? Tell me. 20 into 2, that will be
40 clockwise.
40 kilonewton. It is clear? According to this theorem I have told you, the resolution of a force into a force and couple. So by using this theorem, I have converted this. Okay. Now comes to last part, this one. See, what is here? This is simply a couple. When the couple is there, there is only the movement. There is no other force here. So when the couple is here, so we will directly see here. What is the direction here of the couple? Clockwise. You can see the sense. So direction will be clockwise. And what is the value? 3 into, from where it is coming? C. And this is here to here. This will be 3 into 1 plus 1. So how much it is? 3 into 1 plus 1 kilonewton meter. Or we can say that how much it is? 6 kilonewton meter. This is how you have to solve. This is the couple. If any force is acting like that in the beam, so this is the couple here, and we have to see couple has only the movement, not any force. Only movement, couple has only movement. Okay, so we are writing here the movement. So summation H, summation V, Fy, summation Fx, and summation Ma is equal to 0. Can you able to do it now? I will be writing only the movement equation because movement equation is little difficult. So HA 0, VA 0, 40 cos 50 0. Then now see 40 sin 50 is clockwise, since clockwise it will be negative, into distance is 1 meter, minus this is 120, distance will be 3 meter, minus here. Now what we have to see? This is clockwise and this is the movement. So only movement part will be there. There will not be any multiplication with that. So minus 40 will be there directly because this is the movement here. Minus 40 and what is this? Minus 6 and plus VB into total. How much it is? 2, 4, 5, 7 and 9. So VB into 9 equal to 0. This is equation number 3. 1 and 2 you can make by yourself. I think this is very easy. 1 and 2 you can easily make, and third I have told you. So it is clear now how you have to solve this. Yes.
Yes, sir.
सर ये एक बार सेकंड लास्ट वाला बता दो.
Which one?
सर जो कपल से पहले वाला था ये 20 किलो न्यूटन वाला और 2 मीटर वाला.
See this theorem. I have explained theorem. According to this theorem, I have done it. There was a force acting at point A. I have shifted the force which is acting at point A to the point B. How I will shift? I will introduce two forces here on the B part, and this forms a couple because this is a parallel force, so sense is clockwise, and the force here at the point A is shifted to the point B. So this is, you can see, B is shifted, and this couple has a movement will be F into X. So I have done here same. So 20, this will force shifted here 20, and this is again 20, and 20 will be couple whose movement will be 20 into 2, that is 40 kilonewton meter. And what is the direction here? Direction is clockwise. So I have shown the direction clockwise, and clockwise is negative. So minus 40 and minus 6. Okay. Is this clear now?
Excuse me, sir.
Yes, sir.
Yes.
सर वो सपोर्ट पे आपने HA और BA जो रिएक्शंस लिए हैं सर, उसमें डाउट आया कि डिफरेंट सपोर्ट्स में कैसे रिएक्शंस लेनी है, मतलब वो समझ नहीं आया.
I have told you in the earlier classes, if there is a hinge support, so you have only vertical reaction and horizontal direction, if you remember. And this is the hinge support. And if you have roller support, then you have reaction only in the vertical direction. So accordingly, we have made the directions here. This is vertical, and this is HA, and this is BA for the hinge support. So anything else you want? So you can, yes.
सर इक्विलिब्रियम वाली असाइनमेंट का क्वेश्चन नंबर 33 का भी हिंट दे दो थोड़ा.
Question number 33. Wait.
यस सर.
In question number 33, you can see this is simply a, this is the hinge support here, this is the roller support here, okay. And this you can see, this is 1 kilonewton which is acting from here, and you can see this you can directly take it at 5 kilonewton. This is the 5 kilonewton weight acting here. This you can directly take it here 5 kilonewton. The role here of this roller here is 5 kilonewton, and you can directly solve the equation. And I will certainly provide a hint to all the questions what you have given to me. So I will provide all the hint and solutions so that you can able to solve all the problems. 27, 28, yes.
सर इसी असाइनमेंट में क्वेश्चन नंबर 15 में एक बार आप चेक करना, शायद कुछ मिसिंग है. एटलीस्ट एडी की टेंशन देनी चाहिए थी.
Listen, student. See, you have not read the question clearly. Question says that frictionless pulley A is there. This is frictionless pulley, okay? And you can clearly see that AB and AC are bar. AB and AC are bar. Only one part is string, or you can say cable. Cable is DG. DG means from point D. Sorry, we have introduced a cable, and it is passing over a pulley on the weight 20 Newton. That means you can clearly see this is the cable which is passing over the frictionless pulley, and I have already told you when there is no friction is there on the pulley, tension on both the sides will be same, okay. And you can see the tension here is, or you can say the weight which is hanging should be equal to the tension here. That means AD will be given by 20 Newton. It is clear now? AD is 20
Yes,
Newton,
sir.
okay, because you can see DAG is a string or a cable, and it is passing over a pulley, and it is hanging with the weight 20. So after pulley you can see, so you can see that if I can tell you, if a thing is like that, if a pulley is like that, okay, and if there is weights or the strings here, this is a pulley here, and the other two different cables or the belt or whatever it is, if this is same, or you can say this is frictionless, so this tension and this tension will be same, or the weight which is hanging here or should be equal to this one. So this is exactly the same thing here. You can see in the diagram. You can see it from the diagram. See, DAG, this completely is a cable which is passing over a pulley. So what will happen? This will be one string, sorry, one bar, this will be another bar, and this will be the third bar. So you will be making the diagram like that. I can show you if it permit me to show. Actually, the slide has to change every time. So I think if you can see, it is like that. The question is like that. This one is that, like that, and this one is like that. And from here, the string is there. So whatever the weight here, this will be your FAD, whatever it is, and this will be your 20 Newton. And okay, and this will be your third one. What is it? FBC, I think. Okay, this will be your main point here, A. And what you will do, you will just draw a horizontal line here, and you can see there the angle is given to you. You will find out this angle. Okay, angle is given here also. This angle is given to you. You can find out this angle. So this force, and this force will pass through this point. So ultimately, this will be like that. ABD will be like that. For A point, this is FAD. See this angle? This is 20 kilonewton or 20 Newton, and this is third one, that is FBD or whatever it is. I don't know exactly the configuration. This is I think 30 degree. So you can calculate this one. So you can just make the component. You can easily calculate it. Okay. So rest what I will do. We don't have too much of time. It's already time is running out. This problem is, I think you can do it now. 15. Problem number 15 is clear now.
Sir. Yes, sir.
And after
सर
the
आपने कहा था मंडे को एक्स्ट्रा क्लास ले लोगे डाउट्स के लिए.
I will try if I am free. Otherwise, what I will do, if I am not able to free, whatever the questions you have given to me, I will provide the hint and solution to them. Okay.
Okay, sir.
Excuse me,
Hint?
sir.
Yes.
Excuse me, sir. Actually, sir, yesterday I have mailed my experiment number 3. Did you get it?
What's your name, beta?
Sir, my name is Samir Chaudhary.
Samir, yes, I think I have to check it once again.
Okay, sir.
I think you have not mailed me on time. I remember after the lab you have.
I'm sorry, sir.
After lab you have.
Sorry, sir. Actually, I have not completed my diagram, so that's why I.
But from the future, you can. I am saying
No,
that
sir.
on the day of practical, I will not receive it. I
Okay,
will
sir.
not take it.
Sorry,
And
sir.
rest of the
Sir?
questions you can do it now.
Sir,
28, 28,
Sir, excuse me,
28.
sir.
Yes.
Sir, experiment 3 की आपने readings check करी थी?
No, I have not get the time, but I will check it today. I
Okay, sir.
will explain it by Monday or Tuesday. Okay.
Okay,
Before
sir.
your practical.
Okay, sir.
So rest I will
Solution
show you.
upload
Hints I will give it. I will give to you. Okay.
solutions के solution upload कर दीजिएगा सर.
For all
Say
these
handwritten
assignments.
note.
Handwritten notes. Yes. Give me a time. I will upload the handwritten notes after the lecture. Okay. So just now attendance part is left now. Jashandeep, are you here?
Yes, sir.
Okay. Then 296 Rama. 299 Divyam.
Present, sir.
300.
Present, sir.
301. Shekhar.
Present, sir.
302.
Present, sir.
306.
Present, sir.
307.
Present, sir.
308.
Present, sir.
309.
Present, sir.
311.
Present, sir.
313.
Present, sir.
314.
314 present, sir.
Yes, okay. 317. Vanshweet.
Present, sir.
319. Sankirat. 319. 319 is not here. 321.
Present, sir.
322.
Present, sir.
324.
Present, sir.
325.
Present, sir.
Then 329.
Present, sir.
330.
Sir, present, sir. 330.
331. Shantanu.
Present, sir.
333. Naman.
Present, sir. Naman.
34. Yuvraj.
Present, sir.
35. Kushagra. Kushagra. 36. Nikita.
Present, sir.
37. Pragati.
Present, sir.
39. Arunit.
Present, sir.
40. Himang.
Present, sir.
42.
Present, sir.
46.
Present, sir.
47. Aryan. 48.
Present, sir. 48.
Okay. 51
Present, sir. 51.
and 54. Bhavya Singh.
Present, sir. Present, sir. Sir,
319 present.
319.
9.
Sankirat. Okay.
Sir, 301 Shekhar present, sir.
I have marked it.
Okay, sir.
Excuse
Okay.
me,
Now
sir.
you can, yes.
सर मेरी अटेंडेंस भी सर.
हाँ अमित I have noted our attendance.
ठीक है सर.
Okay.
Thank you, sir.
Thank you.
Thank you, sir.